So that was lovely. That took more time than I thought, but I'm still going to do another proof because I think it fits nicely. It's also about cyclicness. I'm gonna just get rid of this and put it next to my other ones. I like to keep my proofs, um, just in case I'm feeling, what's the word? Not romantic. That is not the right word. Nostalgia. I don't know. In case I want to review them. That I don't know why romantic was the. That is weird. Okay, I believe it's this next one. Yeah, 6.1. That is a very short theorem. Every cyclic group is a billion. Similarly, I hope that this is a short proof. So every cyclic, I'm not even gonna, oh wow, I'm tired. Cyclic group is a billion. Wow, I'm not even caring. You guys, woo, okay. Woo, I'm tired. You guys are probably like, Jordan, get sleep. Yeah, I tried that. Didn't work too well. Why can't I tap my pink? Okay, let's just try and prove this. So we have quite a few tools at our disposal. Let's first go for what it means to be a cyclic group. Um, I'll just kind of write out a very simple definition. If G is cyclic, that's a horrible, I hate this word. Too many C's. I don't know where the L goes. The I looks like an L. And, okay, if G is cyclic, then there exists some A in G such that A generates G. Um, that is for all, we'll just go to B and G. B equals A to the N, where N is some integer. That's like the perfect short little proof. I mean, it uses all the fancy there exists and for all. Makes you feel all math majory. I'm looking at you got these weird angle things. They're L angle and R angle in LaTeX, which I always think of Langle and Wrangle. I'm rambling, but now that we have that defined, how do we show that that's a billion? Well, all you have to look at me. I'm sounding more and more like Epson. I see the horrors of me turning into him and like Duffy and being like, ta-da! And even Professor Clay. He's great. He's a lovely human being, but I feel like he teaches like that sometimes too. What we're gonna do is remember a billion is just that like AB equals BA. So if we take two elements in G, take two elements in G. Once again, I'm being a little lazy and not calling them. I guess we could call them X and Y, but the reason I don't want to do this because I'm going to write them in terms of A anyway. So I'm just going to call them A to the. Let's do R and S again. That's what I did in the last problem. A to the R and A to the S. We will show A to the R, A to the S. This is implying multiplication equals A to the S, A to the R. I could have defined G as having like binary operation star or C dot or something. For those who don't know, this is called a C dot, or at least in LaTeX, it's slash C dot. That's what I call it. Maybe it has another fancy name. But to do that, all we have to do is really look at it. So given a to the r, let's just say, I'll write that out. Given a to the r. Oh, and I need to. Oh no, I said that. Um, times a to the s. We have a to the r plus a to the s, which equals, because the reason this works out where every cyclic group is a billion is because cyclic groups have powers. Powers have this fancy addition property, and addition is already defined as a billion. Um, and that equals a to the s times a to the r. And there you have it. I guess I'll give it a little more. So An arbitrary cyclic group is abelian. Yay. That wasn't too bad, right? I hope this is like kind of like understood, but I encourage you to do these before me, try it out, and then like pause me and pause my wonderful voice and then try it, and then you can watch me and be like, ooh, compare yourself to what I have. Like I said, most of the time what I write is a little too much, probably. I don't necessarily, this is like a little hubris, but I don't recommend going as detailed as I do because the exams are timed, and while I've been able to survive the ticking time bomb, maybe there will come an exam where my rigor eats at me because I end up running out of time. So that's a risk to evaluate as you go about the exams. Anyway, thanks for watching.